be discussing the concept of scalar triple product, that is also termed as the box product of vectors. This is an extremely interesting concept and I am sure you would also enjoy studying it. We shall discuss some of the properties, I would say interesting properties based on the concept, like dot and cross are interchangeable. That means that if you have a term of the form A dot B cross C, you can write it as A cross B dot C. We shall also discuss some of the questions based on this concept. So let's begin. Okay, so the next concept that we have is the scalar triple product, that is the box product. It is also termed as the box product and you'll get to know once we discuss it why is it called so. The scalar triple product of three vectors A, B and C is defined as A cross B dot C is equal to this value sin theta cos phi, where theta is the angle between A and B, whereas phi is the angle between A cross B and C. It is also defined as this. Can you see this notation? A vector, B vector, C vector. So it is kind of enclosed within a box, therefore it is termed as the box product. Let A be the vectors, so it's defined as A cross B dot C equal to this value sin theta cos phi. Means this is the formula for scalar triple product. Then let A be the vector A1i plus A2j plus A3k, B is B1i plus B2j plus B3k and C is C1i plus C2j plus C3k. Then A cross B we have already discussed can be written as determinant of I, j and k, then the components of A in second row followed by the components of B in the third row. And this again this can be written as I into determinant of A2, A3, B2, B3. You just cancel out this, you get determinant of A2, A3, B2, B3 minus j cap determinant of A1, A3, B1, B3 plus k cap determinant of A1, A2, B1, B2. Therefore, now A cross B dot C would be equal to C1 times this minus C2 times this plus C3 times this determinant. And this can be written as determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Therefore, A cross B dot C is equal to B cross C dot A is equal to C cross A dot B, that is equal to minus of B cross A dot C minus of C cross B dot A minus of A cross C dot B. Okay, what am I doing here? I have taken A cross B dot C. This can be written as B cross C dot A. In a way, you can say that the dot and the cross are interchangeable in case of scalar triple product. That is why we can write it as A cross B dot C can be written as B cross C dot A. And similarly, we can write C cross A, now I am interchanging in this case C cross A dot B, right? But if you remember, in case of cross product, we had discussed that if I have got B cross C, that won't be equal to C cross B. In fact, B cross C would be equal to negative of C cross B. Utilizing that property, we can write this to be equal to minus of B cross A dot C. See, from this A cross B dot C can be written as minus of B cross A dot C. Similarly, for these two also we get these two values, right? So this is how we have obtained this is equal to this is equal to so on. Now we have certain important properties of scalar triple product. If you have a quantity like this A plus B, C, D, then you can split it up. This first term can be split up into two terms, that is we can write it as sum of ACD, scalar triple product, plus BCD. And scalar triple product of AAB, that is if you have two quantities same, then we get it as 0. Next one says, in a scalar triple product, the position of dot and cross can be interchanged. This we have already discussed, that if you have A dot B cross C, then instead of this dot we can put a cross, and instead of this cross you can put a dot. That is A dot B cross C would be equal to A cross B dot C, or this means that scalar triple product of ABC is equal to BCA, again cyclic order, ABC, BCA and CAB, right? So we get this. Next one says if A is A1I plus A2J plus A3K, B is B1I plus B2J plus B3K, and C is C1I plus C2J plus C3K, then scalar triple product of ABC is equal to, you can in the form of determinant, what you can do is you can just write down in first row only the components of A, followed by in second row you can write down the components of B, and in third row the components of C. So we get determinant of A1, A2, A3, B1, B2, B3 and C1, C2, C3. The next one says A dot B cross C is equal to minus of A dot C cross B. Now again the property of cross product, B cross C is negative of C cross B. So I have A dot B cross C is minus of A dot C cross B. Or ABC can be written as minus of ACB. So in case of scalar triple product, again you are following the cyclic order. ABC is equal to BCA is equal to CAP. But if you interchange these two, we'll get a negative sign. That is ABC would be equal to minus of ACB. Continuation of properties. A, B, C are coplanar if and only if scalar triple product of ABC is 0. So this becomes important. The next one says scalar product of three vectors, two of which are equal or parallel, is 0. One of them we have already discussed, that the scalar we had two quantities as same, that is two vectors in fact were same. We had scalar triple product of AAB, so that value would be 0. So if any of the two vectors out of three are either equal or parallel, then the scalar triple product of these three vectors would be 0. Scalar triple product of IJK is 1. Okay, if you have a quantity of this form, that is we have K A vector, then B vector, C vector, then you can take out that K outside and into scalar product of A, B, C. Okay, this one again we have already discussed. If we have first vector is of the form A plus B, then you can just split it up and we'll get a scalar triple product of A, C, D plus B, C, D. The volume of the tetrahedron OABC with OS origin and the position vectors of ABC being vector A, vector B, vector C respectively is given by V is equal to 1 by 6 scalar triple product of ABC. Now this is again important. If you are required to find out the volume of tetrahedron OABC, the position vectors of ABC are vectors ABC and O is the origin, then the volume is equal to 1 by 6 times scalar triple product of ABC. So simply you can apply this formula to find out the volume. So that was scalar triple product. We will discuss the concept of vector triple product also, and then we will solve out certain questions based on these concepts. Well, I hope you must have understood the concept of scalar triple product. Now see, all these concepts are quite interrelated. Like in the next session, we'll be switching to the vector triple product. So just practice a good number of questions on all these concepts so that you don't get confused. So in the next session, we'll be switching to the vector triple product, in which we shall discuss some of the properties as well as questions based on the concept. So just stay tuned.